Yesterday's pain? Still paining? Right hand? Okay. Ma'am, you are new? Can you please introduce yourself? I beg your pardon? I beg your pardon, can you repeat? Amruta. Okay. So you are here for a demo or you have joined? Okay. Can you tell me your educational background and if you have attempted UPSC or anything? Is this your first class for UPSC? What is your educational background? Bachelor of Arts. Okay. Okay, done. So you have graduated or you're still in college? You have graduated. Okay, done. Okay, please sit. So this would be your very first experience of UPSC class. Okay. I mean, what a timing you have chosen. Today we are going to do tsunami. Okay. So that way. Okay. So welcome to the class. So if you feel comfortable there, it's fine, or you can come to the front as well. Okay. These people don't mind these people. They are like that. Wherever they want to sit, they will sit. Chalo. There comes our smasher. You are the only person who does not have any kind of pain, I guess. You did not play a lot, ma'am, please. When? Seriously? Only 5-10 minutes I have seen you playing. Okay, I played longer than you. That is what, no. So I saw her playing. I saw him. He was playing with me only. I saw you both were the ones who played the least. You both. Okay. Regardless. So, chalo. Today we are going to start with the disaster management of tsunami. Okay. So we'll understand what exactly is tsunami first. How exactly is it caused? How do we see that in 2004 the Indian Ocean tsunami that hit India and the other countries which have the coast on Bay of Bengal, for that matter Arabian Sea, how did it affect them? And then how we have built upon the system to somehow reduce the impact of tsunami. Okay, that is what we are going to do today. So let us understand this particular Japanese term tsunami and why exactly has this particular term come from the Japanese language. Because the first ever tsunami to be studied was actually a tsunami that hit the coast of Japan in 1896. Okay, so for them at that particular moment of time, they thought this particular wave is the one that can inundate or flood the entire port that was there for Japan. Because when you look at Japan on the world map, you will see that Japan is surrounded by ocean on all the sides. Okay, and they are all parts of Pacific Ocean. So basically Japan has been the most prone to volcanism, earthquake, and then because of those tsunami. Okay, so when this particular concept of understanding tsunami was being developed, so because it was studied in Japan, so we have this particular term coming from Japan. Okay, so tsunami actually means harbor wave. Okay, so this particular word breaks into two parts. Okay, that is su and nami. So this is actually a wave and this is the meaning harbor. So their main ports were the one which would get affected when the tsunami would strike. Why? Because whatever was there on the ports will now be submerged underwater, and because that is going to submerge underwater, now this is something which will stall their fishing, their economy. So that is why they saw that because we are not able to access our resources economically, okay, primarily fishing, okay, because when you talk about Japan, Japan is a very major fishing country. This is a country that actually thrives on fishing a lot of different types of products. They do whale fishing. Yes, whale is consumed in Japan. Shark fishing, shark is also consumed. Okay, there are many big fishes that they actually catch. So when you talk about sushi, how many of you have heard this particular term sushi? So sushi actually is boiled fish, okay, seasoned with other herbs and everything. So this is something which is very widely consumed in Japan. Okay, so when you talk about sushi, so for making sushi you will need fish, and for the Japanese the fish come from the ocean. They don't come from rivers. Okay, so that is why, because they would not get this fish, so it was something that is going to have some kind of impact on their food security. That is why this particular phenomenon was studied. Now, why particularly in Japan? Okay, because when you talk about the world, the most frequent you can say occurrences of tsunami happens in the Pacific Ocean. Okay, so Pacific Ocean is basically the region with the highest frequency of tsunami. And one of the worst you can say hit region with respect to tsunami, one of the most vulnerable regions to tsunami is not just Japan. The most vulnerable region is Hawaii. Have you heard of this particular islands? Anyone who wants to go there? A very popular tourist destination. Why no, sir? Very popular tourist destination. Okay, but when you talk about the Hawaiian Islands, now Hawaiian Islands are located somewhere in the middle of the Pacific Ocean. So this particular islands are vulnerable to tsunamis from all the sides. Okay, from the north they are vulnerable through Aleutian Islands, part of Alaska. Okay, from south and southwest they are vulnerable for tsunamis from the South American side. This is southeastern. When you talk about southwestern part, here we have Japan. All of these places where high amount of earthquakes and volcanism are known to be existing. Why? Because these are actually the regions that actually are lying on a particular zone that is known as the Ring of Fire. Okay, so Ring of Fire is the world's most active zone for earthquake and volcanoes. And why is that? That is because of the fact that we have the Pacific plate here. Okay, this is the Pacific plate and it is in subduction to many small plates, meaning that this Pacific plate is sinking or you can say colliding with other small plates in these regions. And because of this collision, what has happened? There are a lot of active volcanoes, and because of every single movement of the tectonic plate, we have got earthquakes. Okay, so because of these two, we have a lot of triggering mechanism for tsunami in this region. Okay, now what exactly is going to be tsunami for us? These basic facts are clear. Okay, so one more fact you can write down: the most devastating tsunami in the history that has been recorded. Okay, that struck Peru. Do you know Peru? So it struck Peru in 1960. This is the most devastating tsunami ever recorded. Why? Because when you locate Peru, so this is Peru. I'm not very sure you will be able to see, but this is Peru. Okay. Now when you talk about this, so when you look into this particular zone, so you find that about 20 coastal towns, okay, spanning from 22 degrees north south to 36 degrees south, these latitudes, all these coastal towns were either destroyed or for that matter they were inundated or flooded due to tsunami. So that is the most destructive one. It resulted into the loss of 2,30,000 lives alone. Okay, and then complete submergence of many of the coastal towns here. So that is what has been recorded in the history. So when you talk about the Indian Ocean tsunami, it had a combined impact. It was not for a single country. Okay, so Indian Ocean tsunami struck India, Sri Lanka, Thailand, Indonesia, Malaysia, a lot of different countries there. Okay, so it was not limited to one country. This particular event was limited to one country. Okay, so let us now understand what exactly is tsunami. So tsunami is first of all a wave, and wave is a form of energy release. Okay, so just imagine that yesterday when we were all playing badminton, so when we were hitting the shuttlecock with our racket, So what would happen? The shuttlecock would change its direction on the other side. So what exactly are you doing? As soon as you are hitting the shuttlecock with the racket, so your energy, okay, because you are moving, so when you move you have kinetic energy. So because of that, what is happening? This kinetic energy is getting transmitted to the shuttlecock. The shuttlecock changes its direction. Okay. Now it depends upon you how hard you want to hit, the farther it is going to go. Okay. Or where, in which direction are you trying to move this particular thing? So what do you understand? That first of all, in which direction is the force applied? Okay. And how much force is applied will tell you what kind of energy is going to be transmitted. Okay. So for energy to be transmitted, you need to have a force. Okay. And this force needs to displace something. Okay. So that is why understand that shuttlecock example. Now what happens is that as soon as you are hitting the shuttlecock, okay, so what happens? Have you heard that whooshing sound that comes from the air? Why does that whooshing sound comes from the air? Because you are very quickly moving your racket, and as soon as you move the racket, it disturbs the air in the surrounding, and because of that, this air produces sound waves. That is the whooshing sound you hear. Okay. So very bad you guys did not come to play badminton yesterday, so you have to imagine they have seen, so they can remember what happened yesterday. Okay. So what basically happens is this. The same thing happens with respect to aircrafts. So when the aircrafts are actually moving, so what happens is that because of the movement of the aircraft, it actually splits the air because of its body. Okay. And then when it is moving ahead in that particular direction, the disturbance that is created in the air is what is the whizzing sound you hear whenever any aircraft is going to cross through this particular sky. Okay. So do you understand this? So all of these things are actually waves. So energy can be transmitted as waves. Talk about energy of light, talk about energy of sound. For that matter, when we talk about badminton, I told you that is also a kind of wave. Okay. So what is happening? That because of these waves, some kind of movement is going to be initiated. Okay. When you talk about sound, what exactly is the movement that gets initiated? Your eardrums vibrate. And because of the vibration of your eardrum, you are able to listen to a sound. Okay. So that is why, have you, anyone who has gone to ultrasound? Anyone who has taken their ultrasonography, USG? No one? Okay. It's very difficult with you guys sometimes. Have you ever heard the voice of an ant? Ant. Have you? Voice of an ant. You will not be able to hear that. Don't worry. It's not, you can say, any kind of doubt on your hearing ability. The point is that the sound produced by them is something which is not sensitive to our ears. Okay. So we have a certain range within which we can sense sound. Okay. Something that is beyond that range is known as ultrasound. Okay, that is 20,000 hertz. So anything which has a frequency beyond 20,000 hertz, you will not be able to hear the sound. Okay. Anything which is 10,000 hertz and 10 hertz and below, you will not be able to hear that sound. So when you talk about ants, they make a sound, but you don't listen to it. Even their movement is something that you will not be able to decipher. Why? Because their vibrations are very slow. So that is how you are not able to see that. Okay. So in a certain manner, you understand that waves are a kind of way in which we are going to transmit energy. That is why sometimes, let us say that you are looking towards me, but if someone goes from the backside, you still would be able to understand someone was there, someone crossed you by. How does this happen? That is also the disturbance in the air. That is what triggers your senses, that who exactly is behind me. Okay. So those are waves. Now when you talk about tsunami, it is a series of such waves. But how exactly these waves are going to be created? These waves are going to be created whenever the water is vertically uplifted. Okay. So have you ever seen any kind of celebration involving champagne? For FIFA World Cup, Cricket World Cup, F1 Grand Prix, anything. Have you seen that? So what exactly is done? You shake that bottle of champagne very vigorously and then you pop the cork open. So what exactly happens? The champagne comes out. Is everyone able to understand that? That popping of the cork that happens, why does that happen? Because you have agitated the champagne. So whatever you can say the pressure or the vapors were inside it, they have now been pressurized by the fluid inside it. And then what happens? As soon as the cork pops open, this you can say foam actually comes out with some amount of fluid. So what exactly is happening? There is a vertical uplifting of the cork. If this is our champagne bottle and if we vigorously vibrate it, so what is going to happen? This cork is going to come out and then this liquid is also going to come in the vertical direction. So that is the same thing which happens with respect to the tsunamis as well. Okay, there would be something at the bottom that is going to vertically uplift this particular force. And when this force is vertically uplifting water, now this water spreads out in all regions of the world. That is what is going to create a series of waves. Okay, and that is what is going to become tsunami. Okay, so this is what a tsunami is actually. So what would you need to begin a tsunami? Anything that can vertically uplift the water. So vertical uplifting of water can happen in several ways. Okay, how exactly do you see that? When you talk about vertical uplifting of the water, you see that the first thing can always be the subduction between two plates. Okay, so whenever two tectonic plates are coming together with each other, they are colliding. So the heavier of the plate sinks towards the bottom, while the lighter plates remains at the top. So now when the heavier plate is going towards the bottom, so every single inch that it is moving inside, it is going to create earthquakes. Okay, and sometimes what happens is that because the plate is heavy, it is very massive. So instead of easily gliding inside, it starts compressing. Okay, it starts bending a little, and then subsequently after some time it just releases. Okay, so it is just like when you have a spring. So when you try to compress a spring, have you all had that push pen? Have you all broken that push pen? And then you have played with the spring. So what happens when you play with the spring? The spring buckles from the middle. Okay, sometimes it slips your hand and tosses up. Okay, so what basically is happening, that there are two massive forces that are coming from your fingers that is trying to compress it. But when it is getting compressed, sometimes what happens is that you don't realize, but your fingers actually are not in the same line. Okay, there is some amount of eccentricity. Okay, and because of that, what happens, instead of compressing like this, it buckles from the center, and then subsequently it releases from your hand. And then what happens when it releases from your hand? It again comes back to its straight position. Similar thing happens with respect to the land as well. Okay, so when the heavier plate is actually sliding inside, so instead of going in as a straight body, it starts buckling, it starts curving. So when it starts curving, what happens is that after some time, it is now having a very great slope to slide inside. So now what happens is that there will be a time that there will be no further movement. So instead what happens, because there is enormous amount of forces, it rebounds. So when it rebounds, whatever water it has collected, that is projected vertically upwards. So when that is vertically upwards projected, then what is going to happen, this water when it falls down, it is going to spread out in all the directions. Okay, that is the first reason why you have a tsunami. The second reason for a tsunami, if there is a massive volcano underwater, so what is going to happen, volcanoes are going to erupt upwards. So when the volcanoes are going to erupt upwards, what is going to happen, they are going to push this water upwards. That is also going to swell the water, that water will also flow. Third thing, imagine that you are in the Andes mountains, okay, or any mountains which basically are at the coastline. Now a massive chunk of this mountain falls down into the water. The same thing will happen, just like you throw a stone in the puddle. Okay, so what happens when you throw a stone in the puddle? The water splashes out. The same thing happens with respect to these rocks as well, that they are going to fall down, and when it falls down, it is going to displace the water. Okay, a fourth possibility is meteorite strike. So when any massive chunk of rock from the space comes towards the earth, okay, that is known as meteoroid. So when that meteoroid ending at OID, when that enters the surface of the earth, it starts to burn. Okay, why? Because of the presence of air. So air is one such force which resists high velocity movement. Okay, so let us say that you are walking down the street on a windy day with your direction against the wind. Okay, and you have a umbrella open. So what exactly happens? The wind is trapped in your umbrella and you feel that the wind is pushing you back or pulling you back. Okay, why exactly is that happening? Because wind is something which opposes high velocity movement. Okay, try driving without helmet at a windy day on high speeds. You're going to see how much of the fuel it is going to consume and how much eyes you will have watery. Okay, why? Because there is an enormous amount of pressure that is being forced by the wind on you. So that is why what happens is that in this particular case, when a meteoroid enters the surface of the earth or the atmosphere of the earth, it encounters an enormous density of gases in the atmosphere. Okay, and it is falling down because of the gravity of the earth, so its speed is very high. Because of this high speed, the air resists this motion and it starts burning up. That is what is known as meteor. But if this particular chunk of rock is massive enough, it is going to hit the ground, and wherever it is going to hit the ground, it is going to create a dent. Okay, if it hits inside the ocean, then what is going to happen? The water in that particular region is going to splash out very violently. That is also going to create tsunamis. Okay, has this understood how tsunamis are made? So that is what basically is tsunami. Now what happens is that why exactly tsunami waves become so heavy or so big? Okay, now when you talk about the speed of tsunami, this is something which is directly proportional to the square root of acceleration due to gravity and the depth of water. So this h is actually the depth of water column. This is basically acceleration due to gravity. This is a constant. So technically what happens is that the speed of tsunami is directly proportional to the square root of the depth of the water. So if the depth of the water is high, okay, speed will be very high. If the depth of water is low, speed will also be low. Okay, now the point being that when you talk about the tsunamis, if they originate somewhere in the middle of the ocean, the depth of the ocean will be very high, 4,000 meters, 5,000 meters, 6,000 meters. So the speed will also be commensurately high. Okay, but if the tsunami is actually originating from a shallow depth area, the speed will be less. Okay, now the next part about it, it's okay that speed is something, it can attain a speed of 700 kilometers per hour to 800 kilometers per hour in a massive ocean. Okay, so in the Pacific Ocean, when it is actually originating somewhere in the middle of the Pacific Ocean, the speed of tsunami is more than a commercial jet. Okay, that is how fast this water moves. But the point is, because it has a lot of water to carry forward, it is not able to carry this entire water forward. Why? Because there is a very large column of water that you have to push through. Okay, so what happens is that this energy gets transmitted ahead with the water molecules hitting each other and transmitting the energy. Okay, but what happens is that when you reach near the coastal shore, so when you reach the seashore, now what happens is that from the depth of the ocean, now the land rises up. So when the land is going to rise up in this particular portion, the land will slow down. Just more the same way when you are going to walk in this particular street. So as soon as you reach the petrol pump, from there onwards you will not be able to maintain your original speed. Why? Because that's an uphill journey. Okay, so when that is going uphill, you are going to be slower. Similar is the case with water. Water will also, when it is coming over the seashore, it slows down because of this adverse slope. And when it slows down, what happens is that the top portion of water is at fast velocity. The bottom portion of water is having very slow velocity. So because of this, what happens, whatever water is there on the top, it continuously keeps on piling up. while the lower portion of water, which is at the bottom, it slows down, it lags behind. So instead of the water flowing as a single body, it starts building up like a wave. And when this wave strikes the shore, that is when you have a tsunami. Okay. Why exactly is this wave going to be so massive? Because there is a lot of energy that needs to be dissipated. But because you do not have sufficient strength, okay, you do not have sufficient depth of water. So now what is going to happen? Whatever water is there, it will start piling up as the wall. And then this wall is going to collapse under its own weight. Because your lower layers of water are slower and the upper layers are faster. So what is going to happen? This layer will go ahead, this layer will remain like that. So after some time, it is going to fall down. So this is what is a tsunami wave. Any doubts till now? Is this clear to everyone? Ma'am, are you able to visualize something? I am not very sure you will be able to understand everything, but at least are you able to get something? Okay. Chalo. So these I have already told you what exactly are earthquakes, volcanic eruptions, landslide. See, when you talk about nuclear explosions, unless these explosions are massive, you are not going to trigger a landslide, you are not going to trigger a tsunami warning. If they are very massive nuclear explosions, only then this is going to happen. And now these have been banned underwater. Okay. So there are certain treaties that have been solved in order to, that have been signed in order to ensure that we do not test nuclear weapons indiscriminately. Okay. One such treaty is called as CTBT, Comprehensive Test Ban Treaty. Although this particular treaty has not yet been you can say enforced, but this is something that has been signed long back, 1994. Okay. What exactly is the objective? That the humanity goes away from indiscriminately testing nuclear weapons. Okay. So we have seen that nuclear weapons are being tested in all kinds of surroundings. Underwater explosions are very common. Today they are very commonly seen from North Korea. Okay. Once upon a time they were the preferred choice for both Soviet Union and the USA as well. Then when you talk about outer space explosions, that have also been tested by both USA and Soviet Union. So that is why such treaties have become important. Okay. Why? Because they can also trigger tsunami. Understood? Now, this is basically a factual, you can say a visual representation of what basically is the cause for vertically uplifting water. That is the first one that I told you. Earthquakes are a consequence of the subduction of the plates. Okay. So when one plate goes beneath the other plate, so every single movement is going to release waves. That is what is known as earthquake. Now when this particular thing is going to rebound back, that is going to uplift the water. Okay. Same is the case with volcanoes. Anywhere the volcano may strike like this, the volcano may be underwater and that is something that is going to be ejected out, or any of the gas hydrate gets triggered or detonated, that is going to lift the water up. Now what exactly is gas hydrate? Gas hydrate is basically any part of gas, that is methane, that actually is trapped within the crystals of water or ice in colder regions. So when that suddenly naturally gets triggered, it is going to result in an explosion, and that will vertically uplift water. Okay. Crashing of meteorites, that is landslides, and this is basically weather disturbances. But weather disturbances are not going to significantly help you with tsunamis. Okay. They are not going to create tsunamis as such, but yes, sometimes that might happen. Okay. Now in 2022, there was one such explosion. Sorry, 2021 December. This was 25th December 2021. Okay. That was known as the Tonga eruption. Now this was basically near New Zealand. Okay. So when you talk about this particular eruption, this is the most violent volcanic eruption ever recorded in human history. And because of this, tsunami warning was triggered in New Zealand, Fiji, Australia and Micronesia. Okay. Because this particular volcano eruption was something which was distinctly visible even from the ISS. Okay, this was a daytime eruption that happened. Okay, ISS is International Space Station. Now, let us understand what basically happened with India. India also has suffered one devastating impact, that was on 26th of December 2004. Now we are going to discuss that. Okay, this event is known as the Indian Ocean Tsunami. This event is known as Indian Ocean Tsunami, 26th of December 2004. Now, what you are seeing here, all these dotted lines that you are seeing here, they are basically the representation of the plate boundaries. All of them. All of these different lines that you are seeing, they are all plate boundaries. Now, what exactly is the situation? The entire world can be divided under such irregularly shaped massive chunks of rock known as tectonic plates. Okay. Now, these tectonic plates are arranged all over the world as pieces of puzzle. Okay. The only difference is that here there is no defined shape for any particular plate. So, this particular plate that you are seeing is known as the Indian plate. Okay. This part is Eurasian plate, this part is Arabian plate. So, now what has happened is that in the past, India was actually a part of Australia. So, Indian plate was once upon a time a part of the Australian plate. But because of the because of the breaking up of the Indian plate from the Australian plate, India began moving towards the north. And because of this particular movement, what has happened? Indian plate struck the Eurasian plate. It hit the Eurasian plate. Okay. And even now, this particular collision is going on. So, because of this particular collision, what has happened? Both of the plates have started folding. And because of this folding, we have the Himalayan chain of mountains forming. Okay. That is the first impact of it. But this is not the only plate in the region. Okay. So, Indian plate at the same time is also striking the Arabian plate. Okay. And then here, when you talk about this particular region, there is another plate which is known as the Burma plate and the Sunda plate. Okay. These are two smaller plates which are there in the region of Bay of Bengal in the vicinity of Andaman and Nicobar Islands. Okay. So, what basically has happened is that when the Indian plate is colliding with the Eurasian plate, it is also in collision with these plates. Okay. And now what has happened because of this? The Indian plate with respect to the Burman plate and the Sunda plate is massive. So, this particular plate is under subduction here, meaning the Indian plate is sinking while these plates are over the top. So, now what is happening when the Indian plate is sinking and these plates are over the top? So, there is any movement of the Indian plate inside is going to create earthquakes. Okay. So, because of these earthquakes gets a tsunami triggered. Now, on 26th of December 2004, what happened was that there was a great amount of bending that happened at the Indian plate with respect to this region. Okay. So, here the massive Indian plate and the smaller you can say Sunda trench or the Burman plate here, the Indian plate adversely tipped or tilted. Okay. It tilted significantly and it was going inside. Now, because when it was tilting significantly, it started folding like that. So, the resistance to move inside grew even harder. So, now what happened was that when there was no more movement possible, the Indian plate rebounded. So, because of this rebound, what happened? The water started getting collected here. Okay, the water started getting collected here, and when the Indian plate rebounded, this water was vertically uplifted and it spread in all the directions. Okay, so this water moved towards India, Sri Lanka, west coast of India, all the way to Africa, Australia, New Zealand and these countries. It wreaked havoc in about 11 countries of the region. Why? Because the water, when it fell down, it moved as wave in all these directions. Okay. So, now this particular event was something which was not expected by India. Okay. Why? because in this particular time we knew tsunami as a disaster existed, but we never knew that it existed so near to us. This highlighted that we have not sufficiently studied the floor beneath the ocean at these regions. Okay, and after this particular incident, in this entire region, it resulted into the forced displacement of about 1.5 million people. That is 15 lakh people all through this region. They were forcefully displaced. Okay, over 51,000 casualties or 51,000 fatalities, of which nearly 6,000 were in India alone. Okay, 2,25,000 and above those people were the ones who got injured, whose livelihoods were completely lost in the entire region. Okay, so that is why this entire thing is something which was a very, very devastating thing for the entire country. Okay, this entire coast of Tamil Nadu, Andhra Pradesh was very, very devastatingly hit. A lot of the region of Sri Lanka that got submerged under water permanently. Even our own southernmost point, Indira Point, today is permanently submerged under water because of this. Okay, so Indira Point is our southernmost point of Indian territory. Okay, today when you cross towards this particular part, only you see that particular flag. Have you seen KGF2? In KGF2, towards the last scene, there is one Indian flag that shows up in the middle of the ocean. That is actually Indira Point. Okay, and that is completely submerged underwater. So basically, this is something which wreaked havoc. Okay, so here we understood a lot of different things. There were a lot of you can say deficiencies which was there with India. Okay, so we understood a lot of things, and after this, when we took a detailed study, we found out that this is not the only tsunami prone zone in India. We have another tsunami prone zone here, and this is even more dangerously close to the Indian coastline. Okay, the only thing is that here the collisions are not so violent. We are not moving very violently on this direction, so that is why the frequency is less. Okay, this particular region is the one where the frequency would be more, but this is the second tsunami prone region that we have in the country. Okay, so vulnerability of tsunami is on both the sides. Okay, more so on the eastern side and especially Andaman Nicobar Islands. Okay, so this is something which was revealed after 2004. Now, don't be disturbed, but I am going to show you what exactly happened blow by blow in that particular time. Okay, so I have some pictures here that were taken before the tsunami hit and after the tsunami hit. Okay, so this is basically what happened at the coast of Thailand. This is Thailand. Okay, tourists are here, and this is the coast of Thailand. So this is basically the scenario when the Indian plate was subducting inside the Burman plate. So all the water which was there on the coast, it started receding and collecting at the site of subduction. It resulted into such receding of the coastline. Okay, so you can see even the boats are having very shallow depth to come there. Okay, so people actually started going inside this because they thought this is some kind of miracle that is happening. This also happened in India, but the same thing happened. Okay, and then minutes later, this is what came up. That is the hitting of tsunami that you see. And see, the only thing that is visible out of this boat is the mast, nothing else. Okay, so this tsunami, when it was hitting Thailand, it was not having such an aggravated impact that it had on India. On India, when this particular thing struck, the height of the wave was 30 meters. 30 meters is nearly 11 to 12 stories of a building. That high waves. Okay, this was very fast indeed, but that was not something which was as tall. Okay, now I am going to show you the aerial version of this. Now this is basically the Sri Lankan coast. This is Sri Lanka. Okay, and this is the normal coastline. This is the normal coastline. Okay, what exactly are you seeing? The direction of water, is it trying to come back? Because the waves have hit the coast, now they are coming back. Now see what happens. This entire water empties out into the ocean. This is the coastline that got exposed. Okay, and then this happens. Now that's a tsunami striking this coast, and then this entire part now is completely underwater. This is the Sri Lankan coast, what you are seeing, and this inundation has just begun. The tsunami is hitting here. So this was a satellite image that was taken that time. Okay, I tried very hard to find something from India, but I could not. Okay, and some of my own pictures that I took as a kid at that particular moment of time, they're already lost. Okay, who would keep these images? I mean, that time, because I was there in Andaman Nicobar, so that is why I had some pictures clicked, but I did not see the actual tsunami. I saw the flooding. Okay, but this is basically what was there in this you can say, I could say, take out from Google. Understood? Now, what exactly this tsunami told us was that we are not very well prepared for this. Okay, so let us first of all understand what were the limitations identified, and then based upon these limitations, what has happened is that we have come up with the various solutions. So the first limitation that was identified was that lack of bathymetric surveys and paleotectonic knowledge. Don't worry about these terms, that is what we have been talking about. Bathymetric is the study of the depths. Okay, so when you talk about the study in the ocean, all of them are bathymetric studies, because you are studying something below the surface of the water. Paleotectonic, rock and their interaction at the tectonic boundaries. Now this was something which we did not pay very close attention to. So this was an academic limitation that was there with India. Second limitation beyond this, lack of knowledge and awareness amongst the citizens. That was the second thing we understood. That is why people, because they did not know what is happening, they went inside the ocean. Okay, had you known this, you would have understood that okay, this is a marker of tsunami coming up. Okay, because you did not know it, so this happened. Third, lack of public address system and early warning system. There was no early warning system that was ever installed. Okay, that was the third limitation that we identified. Fourth, lack of enforcement. For coastal development. So when you talk about the Ministry of Environment and Forest, since 1981, during the time of Indira Gandhi, the first coastal development regulation, you can say, scenario was the one which was prepared, that all the coastal states of India, they must be prepared for certain disasters that might strike the coast, and for that several committees have been made. Okay, that till what level should we have coastal construction allowed and till what level we should not. So one of the earliest recommendation of this was that whatever is the high tide line, till whatever extent the high tide comes into the coastal regions, from that particular baseline 500 meters inside the land, in this particular zone there should be no development, no construction. This zone should be left out for vegetation. This zone should not be having any kind of population, any kind of resort, any kind of infrastructure. That was one of the first recommendations. But this recommendation was the one which has repeatedly been violated. That is why today wherever you go to Goa, you go to Chennai, you go to Puducherry, go to let us say Vishakhapatnam, you are going to find that the development that is being done is dangerously close to the coast. Okay, you will find major arterial roads of these particular cities at the coast. Why? Because we the humans don't understand this, that view is one part of the story, survival is another part of the story. Okay, so because of this, what happened? Because of the lack of enforcement of coastal development, we were hit very hard. There were a lot of coastal communities which were densely populated, all submerged, everything submerged. Okay, so this particular thing was one of the first identified lacunae of the administrative failure. Okay, this is something which was missing in their public resorts. Nowhere in these particular places, although they are vulnerable to hazards, they are the ones who face cyclones, storm surges. Okay, but still there was no public address system. So when there was no public address system, how exactly are you going to let the people know? Okay, and at that particular moment of time, we did not have WhatsApp or Instagram or anything that we are going to put up the status and people are going to understand it. That is not the case. So there, the message was to be transmitted only through two things, either telephone or print media. But then again, understand the plight of places like Andaman Nicobar, for that matter Rameshwaram or Lakshadweep. They are already segregated from the mainland. So when they are segregated from the mainland, any communication that is going to come here will have significant lag. Okay, that is where it was realized that no, we need information communication technology to be strong. We need satellite communication to be there. Okay, that is how we see that this entire thing has developed. So our entire plan actually rests on these things, and primarily our plan depends upon early warning system. So after this, we come up with the early warning systems. Okay, and sad to say that initially after this particular disaster, it was said that we are going to install 12 you can say tsunami monitoring systems across the Indian Ocean region, most of them in the vicinity of Bay of Bengal, 2 or 3 in the region of in the Arabian Sea. But till date, we have not installed them all. Okay, sanctioned was 12, working are 6. Okay, so that is how we live under threat 24/7. Okay, now talking about what exactly have been the guidelines by NDMA. So the only obvious guideline that you are going to see here is that in order to protect people from inundation, in order to protect people from drowning, what is the first thing you would need to do? Take them to a site where the water is not going to come. That is higher ground. That was the only instruction that was also passed on to us as public when we were there in Andaman Nicobar. That okay, there what is going to happen? You have to just go to an upward place, higher ground, that's it. Okay, and at that particular higher ground, what is going to happen? The water will not come inside. So when the water is not going to come inside, the first threat is eliminated of drowning. Second thing that can be done is that you would not want any kind of construction, okay, within the first 500 meters of the high tide line. Okay, why? Because in this particular zone, you may have any kind of water level rising to at any point. Okay, the water level can rise to any point and there is no way that you could be saved. Then subsequently it was said that if you want to construct anything here, okay, so the construction should always be based upon tall stilts. Okay, so tall stilts basically means pillars. Okay, now over these pillars should extend at least till the height where the maximum recorded you can say high tide line is. Till whatever point you have the highest tide coming in this particular zone, at that particular moment at least you should be having these pillars, and based over that you should be having all the construction done. Why? Because this is again going to ensure that nothing is going to be blocked. Okay, so these are the 3 logical guidelines that were given. Apart from that, what exactly are the other recommendations? So here basically we want to ensure that the natural beach sand is nourished somehow. What has happened is that when you talk about this particular region, in the time of 2004 and before that, a lot of sand mining used to take place at the coast. So because of this, what has happened? That the coast did not happen to have significant amount of resistance to the incoming water because the sand is taken out. So when the sand is taken out, what has happened? The plane, the distance of the plane is reduced to half. So if that is the case, the water will not be slowed down. So what needs to be done? We need to recompensate for that. Okay. The next thing, one very important aspect that was realized was the role of the forests at the level of the coast. Okay. So when you talk about the plantations of coconut, casuarina, mangroves, now these were basically such plants or such trees which significantly you can say stopped the impact of the entire water. Okay. So those regions in Tamil Nadu where the mangroves existed, or these particular you can say plantations existed at the coast, they were significantly less damaged than the other regions. Okay. So that was the next thing that was understood, that we need to have green belts. And where would we have these green belts? 500 meters from the beach, the zone where we do not want any construction. Why? Because in this region, if you have a lot of plantation, this plantation will act as obstruction, and this obstruction is something which will slow down water. Okay. Then at the same time, you would want to nourish the beach. That basically means this beach nourishment is about preparing, sending in sand and other sediments. Okay. So that is something that you would want to do. And then sandy ramps at the close of interval. So this is something that we are going to see, don't worry. You are going to see a lot of pictures here. Now, what exactly is the first part of preparedness? We should have early warning systems. Okay, so early warning system would be a multi-tiered system, because this is something which is going to happen off coast. It is not something that is going to happen on the site. It is something which will happen far off in the coast, okay, deep into the water. So from there, timely intervention and you can say communication to the center which can analyze data. Okay, from there it is going to be then sent to the designated authorities, and from there it is going to be released for the knowledge of the public. So it is a three-step system. Okay, so that is why we need to have warning systems for the population. Then at the same time, what are the protective measures to mitigate the tsunami effect? So where exactly are you going to evacuate? Where exactly evacuation is not required? That is something which needs to be done. And what exactly are the action to be taken by the residents? So it was very clearly understood that we have ignored two things. One, enforcement of the laws, that okay, 500 meters from the coastline should not be the place of development. Second, we never considered that the traditional knowledge of the people, especially the ones who are living in Andaman and Nicobar, that is something which is worthwhile. Okay, and to the shock of everyone, when you talk about the tribes of Andaman and Nicobar, which was supposed to be the worst hit, not a single person was drowned. No one suffered any kind of casualty. Why? Because they were more close to the nature. They could understand the science of the nature apart from the animals. Okay, they could understand it. And subsequently, that is why when the tsunami came at that particular moment of time, they were already on higher ground without any assistance. Okay, so then we understood, okay, indigenous knowledge is not that bad. Yes, true. And that is how we have now started integrating that part in this particular idea as well. Okay. So see, this is the early warning system that we have developed now. So what exactly is this early warning system? Just one more thing I like to tell here, and that is basically something which is known as base pressure recorders. You are also going to see a similar mechanism with respect to DART system. Okay, we are going to see that as well. Now what exactly is the system, or what exactly is the concept here? I will just tell you that. After the tsunami, what we did was that in the regions which we identified as tsunami prone, from where tsunamis could originate, there at the bottom we installed certain sensors. Okay, they are known as base pressure readers. So just imagine if this particular bottle represents a column of water. Okay, so column of water is like this only. Okay, from the surface all the way to the bottom. So at the bottom, what is going to happen? You would have certain sensors. Okay, now these sensors are actually sensing the amount of pressure that is created by this entire height. So when you talk about the pressure of water or pressure of any liquid, okay, that is proportional to its height of column or depth. Pressure is directly proportional to depth, or for that matter you can call as height. Okay, mathematically all of you have seen this particular equation. Anyone, all of you who have studied it in class 11th and 12th. Okay, those who have not, no issues. It is basically given by this particular equation, rho gh, where rho is the density, g is acceleration due to gravity, h is the height or depth, this height or depth. Now imagine that this bottle represents the column of water which is under our observation. Okay, the bottom represents the floor, the top represents the free surface. So now what is going to happen, at this particular bottom we have installed one sensor. Okay, so this particular sensor is continuously giving us the reading of the weight of the water which is here. So when you talk about this rho and g, that gives you the weight of the water, density multiplied by acceleration due to gravity. This is something which is going to give you the weight of the water column. Okay, when you are going to multiply it with h, that gives you the entire mass of the water. Okay, so now what is going to happen, when the amount of water in this particular zone is going to be full, that basically means this is the height of water, so this is a normal weight of water. Okay, so the reading is not going to change. But if imagine the height of water column increases, now this is the new height. So what is going to happen, this plate is going to feel more pressure because the height has increased. It increases further, then what is going to happen, more amount of weight. Now this weight, when it changes, then what triggers is that this is something which starts sending this particular signal to the base station in Hyderabad. Okay, so in Hyderabad we have the Indian National Center for Ocean Information Services. Indian National Center for Ocean Information Services, known as INCOIS. So in the entire Indian Ocean region above the equator, so that is the North Indian Ocean region, this particular organization is designated as the regional center for tsunami warning as well, because India has the most advanced kind of you can say tsunami detection systems here. So now what happens is that the signal gets relayed to this particular center. Now the people at this particular center are going to identify what exactly has been the event. Has there been any warning of earthquake from this particular region? And then what exactly is the height of the water column we are seeing? In what duration is this particular column changing? So every 15 seconds it starts sending this particular signal, okay, to INCOIS. And once that particular signal is processed, if it is a tsunami, so that tsunami warning is then sent to the MHA, Ministry of Home Affairs, and the you can say the National Executive Committee for NDMA. Okay, and based upon that, then the tsunami warnings are issued. So we have a 3-tier tsunami warning structure. Okay, the first one is known as tsunami warning, the second one is known as tsunami alert, and the third one is known as tsunami watch. Okay, so these three represent the most you can say imminent kind of warnings that are to be given to various regions. Okay, so when you talk about tsunami warning, now this is something which is the most important and the most critical kind of you can say most critical kind of warning. This is going to be given to those places where tsunami is going to be imminent. So when a tsunami is detected, that tsunami is going to come, so these are the places which are going to be the first one to receive this information. So the district magistrate here, the NDRF and SDRF forces, the state government is going to be informed about it, and immediate evacuation has to be done. So that is why this is known as the code red color. Okay, so here all the public address systems, all the sirens and warnings, they are all going to sound up simultaneously, so that the people near the coastal regions, the one who are vulnerable and who are going to face this disaster head on, they are the ones who are mandatorily evacuated. Okay, so that is the first one, no delay at all, you have to immediately take action. Then the second one is tsunami alert. So when you talk about tsunami alert here, basically what happens is that this particular region is the one where you can say that the tsunami is going to reach at a different time. Okay, so while the tsunami is going to come here, it is not going to come very deep inside the continent or very deep inside the landmass. So that is why this is basically the region where you have to be ready for any kind of evacuation, but right now evacuation is not required. So they are given orange color. Okay, so this code is orange color. Here you have to be ready with everything, but you do not have to evacuate. Okay, third one is tsunami watch, meaning this is something which can be you can say upgraded to a tsunami warning in the coming time, but right now you do not have any kind of such hazardous situation. Okay, So when you talk about this particular tsunami warning, here there is something known as run up. So the run up will be is more than 2 meters. Here the run up will be 0.5 meter to 2 meters, and in this particular part the run up will be 0.5 meters. Now what exactly is run up? So there is an average height of water waves and tides when they come and hit the coast. So when that average height is exceeded by 2 meters, the first one is going to be triggered. When that average height is exceeded by any height between 0.5 meters to 2 meters, the second type of warning is going to be triggered. And when it is less than 0.5 meters, the third type of warning is going to be triggered. But for these to happen, there must also be a concurrent earthquake that must have happened in that region. Only then these warnings are going to be triggered. Okay. Now why exactly am I telling you these colors? Because recently UPSC has already asked the color coding warning for cyclones. Okay, there has been a question for color coding warning of cyclones, and surprisingly that was in paper 1. Okay, where you are supposed to be writing geography, not disaster management. It came there. So that is why there is a lot of intermingling between these two. Okay. Then you have tsunami information. Now when you talk about tsunami information, this is something which is given as an information. Here no kind of you can say action is required. You have to just stay alert. Okay. Tsunami cancellation is basically the one which is going to happen when the event has subsided. So that is green. Okay. And then when the tsunami is completely gone, it is white color. So these are the 3 stages of warning that we have in the country. Okay. Then who exactly are the institutions who are going to be involved here? The first one is Indian Meteorological Department, IMD. IMD is going to watch for storm surges, the swelling up of the water due to storms. Okay. So this is basically going to give you the earthquake, rainfall versus the storm surges result. The next one is INCOIS. Now this is basically the one which is our primary tsunami watching center. Okay, this is a tsunami monitoring center, INCOIS. So they are the ones who are going to process this data, and after processing the data, they are the ones who are going to authorize the issue of the tsunami alert. Okay. Then you have Ministry of Home Affairs. Now this is basically the one where the public dissemination of information will start. So INCOIS sends it to MHA. Okay. MHA is going to send it to the state, whatever state is going to be hit, and then subsequently from the state, all those regions which are going to be vulnerable. Okay, the district collectors of them, they are going to be informed. Okay, and then you have the ports and the harbors in these particular regions which need to be closed and evacuated. Okay, then police, then local NGOs. So then this part is basically information dissemination. Here the information is coming to the public. Beyond this, it is all departmental. Okay, so this is basically how the multi-tier communication system works in the country. Okay. So because I have already told you these, let's go ahead and understand the deep ocean assessment and reporting of tsunami system. Now this is something which was developed by USA. Okay, but this is something which we have also imported from USA. Okay, so here there are 2 components of this system. This base pressure, this is the sensor. It is connected to something known as a buoy. This is known as a buoy. Have you heard this particular term? Buoyancy. What is buoyancy? Everyone hears it, no one asks it. No idea? No idea. Related to floating. Yes. Yes. Water will float on oil. Water will float on oil. What is buoyancy? You also come from the background. Don't think I forget it. Madam Smiley has always given me that. I am smiling, that means I don't know it. If she knows it, she gives a bigger smile. Okay, so I understand it from that. Okay, I am CSE, I don't mind. I don't know it. It's like that. Now, all of you have done this in your school days. I'm not sure if you have done this or not, but I feel you have done this. In a bucket full of water, have you ever tried to put down the mug in the inverted position like that? What would happen? Till the time you have your hand over it, it will remain submerged. But once you release your hand, that is buoyancy. You have seen it, you have never articulated it. Okay, so buoyancy is basically an upward force which is exerted by water over everything. Okay, so it is exerted over everything. The point is, some of these things float naturally over water, just like plastic floats over water. Okay, why? Because the density is less. That is where you have Archimedes' principle coming up. And Archimedes' principle actually tells you that what is the volume of liquid displaced when a particular substance of certain density is going to be placed inside it. Okay, that is why the Eureka moment was there. You know the Eureka story? I only told you, or you knew it. What is the Eureka story? Yeah, that is what, no? That is only you remember, none of these remember. I spent the same amount of time with you guys. Are you sure? Sure. I have done this. Go back to your classes in April. I have told you about Eureka. I told you. See, Archimedes was very close to his friend, the king. Okay, now the king, he wanted a new crown for himself. So he asked the goldsmith that I want a new crown and you are supposed to give it to me. Okay, so on the date of delivery, this particular goldsmith brings this particular gold crown, but the king is not very confident that this is having the exact amount of metal, that is, it has the exact amount of gold that was required to be there. So he asks Archimedes that before I make this payment, you have to identify if this particular goldsmith is saying the truth or not, because the goldsmith says that no, as per your specifications and whatever was the weight you required, that is the exact weight of this particular thing, but he felt otherwise. So he asked Archimedes that you should be finding it out. So Archimedes was the CID at that time. Okay, now Archimedes was also in the loss that how exactly am I going to do this. He went back to his home and then he said, okay, like us, the day is gone, now let's chill. So he went into his bathtub, okay, which was full with water, and he was there. But while he was lowering himself into the bathtub, he could see that water is spilling out. Okay, so first it struck that okay, where I am getting in, so water is spilling out, no issues. Next time what he did, he collected this water. Okay, he again refilled the bucket, the tub, and then he collected this water, whatever fell down. Okay, he did it over and over, and then he realized one thing, that if a particular density of object is going to be immersed inside water, okay, every single time it is going to displace the same amount of water. Okay, and this is what made him realize that if the new crown is as good as the old crown, then if both of them are going to be submerged into the water, they must displace the same amount of water, because the weight is essentially same. Okay, and realizing this, he ran naked to the king's court shouting Eureka, Eureka. So that is what Eureka is. I told you this story. This is the second time I am telling you this story. Now you are going to pay me for this. Okay, so now technically what happens is that we have from this word coming another word that is known as buoy. Okay, now buoy is actually a floating device that is found on the top of the ocean. Okay, so it looks something like this. This you are going to see if you have seen Pushpa 2. How many have seen Pushpa 2? So when he crosses over towards Sri Lanka and this that police actually starts shooting, there are certain orange, have you seen those orange ball kind of things? Those are this. See, I can tell you even from the movies what is there, but you have never seen it like that. They are buoys. What exactly are they doing? They are actually there to receive the data. Because from this depth of the ocean, you will not be able to directly communicate with the satellite. So that is why this is something which is anchored with the pressure plate. This is going to be the one which is going to receive the data. Okay, this data is transmitted here, and from here it is going to be transmitted to the satellite. From satellite it will come to the receiving station. That is what is the system. Okay, so this is known as DART system. So this was something which was you can say placed in the oceans around the US, especially the Pacific, in the 1960s only. But even today this is one of the most important ways of early warning system. Okay, and it works on the exact same principle. When the height of the water column is going to change, it is going to trigger that warning. Okay, so this is basically what is there. So we have already seen these organizations, as I have just told you. Okay, don't worry about NIOT. NIOT is not very important for you. You should understand this. INCOIS. This is the one which is the regional tsunami warning center. Okay. So now coming to evacuation notification, this is something I have given. Yeah. Now let us talk about the mitigation. So there were certain things that were understood after the tsunami of 2004. First, that was basically the presence of coastal vegetation. Second, that we need to have multi-purpose rescue centers. Just like in the last class, you remember snow avalanche also, we had one particular setup where you would be having shelters so that you can save yourself from the avalanche. Okay, so in a similar manner, we need to have multi-purpose rescue centers here. Now these rescue centers are basically the ones which are going to be you can say having the concept of food and ration apart from backup power. Okay, so this is supposed to be working as a single operated entity, and that is something which will be stocking food, adequate supply of medicine and water, and then at the same time it will have functional toilets. Okay, so here is basically the place where the people are going to be evacuated. Now they are going to be built upon the same you can say principle that I told you, stilts. Okay, so nothing is going to be there till the level water can inundate. Everything will start above it. Okay, so that is what is basically the concept here. So when you talk about bioshield, so bioshield is basically all the coastal vegetation, all the natural things at the coast which can act as a barrier. Okay, now that could be the presence of various kinds of plants, that could be the presence of coral reefs, anything that can retard the flow of water inwards is basically known as bioshields. So right now what you are seeing is that this is seaweed that is being planted over the sand. Okay, now what is going to happen, that eventually this seaweed is going to grow tall as grass. Okay, and then when the water is going to come into this particular part, it is going to absorb a lot of the speed of the water so that it does not have a destructive force towards you. Okay, so here basically you have lines of plantation that is basically done on the entire coast. Okay, now what also happens is that a similar thing is what you understand as the shelter belt. Okay, now shelter belt is basically used in the regions to prevent wind erosion. Here also there is a similar concept. What happens is that you would want to have graded height of the plants. Okay, so initially the height of the plants is going to be small, but as you come inside the coast, the height of the plants are going to be more. So now you are having grasses. After this you will be having some medium sized trees. After that you will be having trees like coconut. Okay, so what is going to happen because of these two things happen? The velocity of water which is coming inside is going to be reduced. Second, the velocity of wind is also going to be reduced. So because of this, whatever propulsion the wind is going to give to the water, that will be reduced. You will not be getting inside very quickly. Okay, so that is what is bioshield. Okay, Now this is a very low cost alternative to any kind of you can say construction. Why? Because this is something which can help you reduce greenhouse effects as well, because it's plants, so they are going to take out a lot of atmospheric carbon for photosynthesis. At the same time, they will prevent coastal erosion as well. Okay. The second thing, mangroves, they were the first defendants or the first line of defense that the places which had mangroves experienced. Okay. So mangrove is something which is having such very complex root structures. Okay, and these are dense bushy forests which are found at the coastal region, highly tolerable to saline water. So they can grow in saline water, and they have aerial roots known as pneumatophores for exchanging water from the air, exchanging oxygen from the air. So what happens is that because of their dense congregation or assemblage, okay, and very entangled kind of root structure, they act as efficient barriers against both storm surges and at the same time tsunamis. Okay, so wherever they were present, they significantly saved the population beneath them. Okay, so that is why mangroves became one of the most important aspects of discussion. Okay, that mangrove forests should be conserved and rather their extent should be enlarged. Okay, so that is basically why they have come up as one of the most important lines of defenses. So world's largest continuous mangrove plantation or mangrove occurrence is found in the region of Sundarbans, okay, shared between West Bengal and Bangladesh. Then the next one is basically there in Bhitarkanika, that is in Odisha. Okay, then we have smaller and smaller pockets of this in Tamil Nadu, also in Gulf of Kutch. Okay, so mangroves are present in all across the you can say coast, but intermittently. Okay, what exactly have been the structural measures here? That is the planting of these trees, casuarina trees. Okay, they have been found to be one of the most effective ways of reducing water velocity. Okay, so they are basically the ones where agroforestry has been promoted. That based upon this, we can be significantly reducing the impact of tsunamis. Okay, then at the same time, what has also happened is that sometimes because of the you can say because of the massive sizes of the plants, transplantation vegetation is basically something which is seen that okay, the vegetation does not prevent natural erosion. So if you have smaller vegetation, okay, let us say you have smaller plantations there, that is not going to stop it. You will need resilient, hardy, saline or salt tolerant species. Okay, because what happens when the water is going to come from the seaside, it will be salty. That is going to enter into the soil. So only those species which are going to be salt tolerant need to be here. Okay. Then at the same time, a lot of beach correction measures where we talked about beach nourishment, adding more amount of sand there. Then physical, you can say structural barriers also. Okay, that is something which will be utilized. I'll just show you the structural barriers as well. Now when you talk about emergency tsunami rescue shelters, now they are basically the ones which will be multi-purpose for the coastal region. Why? Because coastal region has three very important vulnerabilities: tsunami, more frequent than that cyclones, and based upon cyclones, flooding. So that is why these places are the ones which should be having shelters, and they are basically the ones where the people are going to be evacuated for a certain period of time. So these shelters need to be the one which should be fully functional. Okay, so they are basically the ones which should be having proper ventilation system. They should be having well stocked up ration, pantry, okay, and at the same time power backup as well. Okay, so this is basically ETRS. So they are going to be you can say located in the regions which are known as the higher grounds, where the water is not going to come, so that at least the mobility of the people is not stopped. Because what happens is that if the place is completely surrounded by water, so technically you are all on an island till the time the water recedes. Okay, and the water is going to recede naturally only, you cannot do anything about it. So if this particular place is located at a higher ground where the water is not going to inundate, people can easily come in and go out. So the crowd can be steady. But if imagine that you are surrounded by water on all the sides, no one will be able to come in or get out. At that particular moment of time, there will be more population inside this particular shelter. That can lead to suffocation. So that is why you need to be very careful while you are selecting the site for these shelters. Okay. Then they should basically be the one which should have certain you can say segregations based upon the needs of the people, especially the differently abled and the women. Okay. So they cannot be functioning as a community setup. There has to be some amount of special provisions that need to be done for them, and they should be very clearly visible from a very large distance, that okay, this is something which is to be used when the siren is sounded. Okay, so that is where everyone needs to reach. So it should be accessible from all the sides. Okay, so wherever you are, you can reach there within minimum amount of time. That is something which is required here. Okay, and evacuation time is something which is needed to be done based upon the human walking speed. You will not be able to evacuate everyone over motorized vehicles. Okay, so based upon what would be the average human speed, okay, of the people who can walk, and at the same time the elderly and the physically challenged, or for that matter differently abled. So based upon their speed of evacuation, you have to timely announce the warnings. Okay, you cannot expect the people to keep on running. So that is what needs to be done. And then okay, cooking facilities and everything I have already told you what exactly is required and not. Okay, now based upon that we are going to read coastal erosion. Okay, one of the impacts of tsunami is coastal erosion, but because of this a lot of valuable amount of land is also lost. Okay, so let us read this and then we are going to go to the structural measures here. Okay, so when you talk about coastal erosion, so coastal erosion is when the land is broken away by the water. There are two things, either the water is going to submerge the land or the pieces of land are going to be separated out into the water. Okay, separately what can also happen is that there will be intrusion of the salt water into the soil. That is also going to cost you the fertility. So that is what is known as coastal erosion. So this is something which is directly going to threaten the infrastructure and human settlements. Apart from that, it can also disturb the ecosystem of wetlands. Okay, those estuaries which might be here, they are going to be disturbed. Now when you talk about coastal erosion is not something which will be immediate. This is going to be a very gradual you can say development of a lot of different types of hazards together. Okay, so when you talk about the cyclones when they hit, when the tsunamis when they hit, so gradually what happens is that there is submergence of the entire region. Okay, that is what is known as coastal erosion. So when you talk about coastal erosion, the first and foremost one is a continuous process of waves striking the coast. Okay, so this is something you have also seen with respect to the geomorphology part, that when the waves are going to strike the rocks on the coast, the rocks are going to be broken. Okay, when the rocks are going to be broken, what is going to happen? The land is going to recede inside. The land is going to be broken. So that is basically the first one, that is known as coastal erosion. So when the land is going to be reduced towards the main you can say towards the living regions, so what is going to happen? Less amount of land is going to be available for you to settle. Okay, and gradually what is going to happen? You will reach very close to the water interface. Okay, that's the first part. Then at the same time, sometimes they also are going to have the sediments coming up. So all these sediments which are going to be deposited over the land or that particular region, it can also submerge your entire settlement. Okay, then when you talk about warmer temperature of the oceans, now this is something which can expand the water. Okay, so when the temperatures are going to increase, the water is going to expand, but apart from that the water level may rise. Why exactly can this rise? Because ice is something which can be melted in the regions of polar you can say at the polar ice caps. So when the ice is going to melt, when the glaciers are going to break down, in that particular time the water will actually have its average rise, average level raising up. So because of that, whatever was the level of water before in the normal years, now the level of water is going to be more. So gradually it is going to advance towards the land. Okay, that is another part. Then when you talk about the other reasons, that will be unplanned construction, mangrove clearing, river damming. Okay, why? When you talk about unplanned construction, in that particular scenario what happens is that you are going to have some kind of foundation built into the system. Okay, that is going to break or disturb that particular land, and in that part you are going to see that the sand gets weak, or you could be taking out the sand. Okay, if you take out the sand, that is also going to reduce the coastal landform. Okay, if you are actually removing your mangrove systems, so mangroves slowed down your water. If there is no mangrove, you are going to be very strong with respect to the water. Okay, so that is also something which is going to break away things. So in that manner we see that coastal erosion is something which can be done by these, and because of this what happens? First of all, we will have submergence of the infrastructure, talking about roads, Okay, your farmlands whichever are there nearby, they are going to be completely submerged. Okay, then there will be damage to ports as well as resorts as well. Okay, then at the same time we see a lot of coastal communities live very close to water, because they are the ones who actually are going to fish, and then subsequently they come back to their places to sell the fish. Okay, so they are the ones who are going to have their houses completely submerged or destroyed for that matter. Okay, now salt water, which is basically going to be present from the sea, if the erosion continues to grow, so we are going to lose a lot of our own agricultural fields which are deep inside the land. Why? Because the salinity is going to make us lose that particular fertility. And then subsequently a lot of wetlands and the habitat zones of the estuaries are going to be distorted. Okay, so that is basically what are the major impacts of coastal erosion. Any doubt? Are you guys alive? I don't think so. Go take a break. But come back at 205. Come back at 205. We have to start this. What? What? 200? 200 rupees he should pay to you. Why? Oh, to tell the secret. So you are still doing that deal. I'll tell him for free. I told you the secret. You pay me that money that I should not tell him. So then you pay that money to me, no, that I don't tell him. What is stopping me? Okay, we are having a test because he talked about money now, so I'll make it free. We are having a test this week of geography and disaster management. Okay, 30 questions objective, 3 questions would be descriptive, subjective questions. Okay, so that is what you would be having this week itself. I'm not sure what date, you will be told the date, but you will be having it. Okay, questions will be set by me. This time the questions will be set by me. Okay, so be ready. And I'll still tell you the questions are going to come from the basics. So read your basics well. If you're not reading your basics well, I'm very sorry. You'll not perform well. Okay, your questions are going to come from basics. Chalo. Now that I have your attention and I have absolute deathly silence, I can start. Okay, chalo. How exactly are you going to manage this particular situation? If there is erosion, erosion can only happen when you have sufficient striking force and velocity, right? So if you have to manage this particular erosion, what would you want to do? Reduce the velocity. If you are able to reduce the velocity, erosion will automatically reduce. So in order to reduce the velocity, what can you do as structural measures? Okay, what artificial structures can you make up? That is something which is known as sea walls and wave return walls, revetments and rock armor, groins and breakwaters. They are all engineering structures which are built and they are installed inside the water at various places having various geometries or shapes. Why? Because you would want the water to break very easily. Okay, you do not want the water to actually hit very hard to the coast. Okay, so when you talk about sea walls and wave return walls, now they are basically the structures on which the water is going to strike, okay, and then it is going to return back. Okay, so it will have a shape like this, okay, like a ramp, and the point is that you are going to shield the entire coastline with this wall. Okay, so just like when you talk about the regions of Mumbai, at various places you are going to find that there are long stretches of sea walls which have been made. Why? Because these regions are the one where erosion has been very high. Okay, so there what basically happens is that you are going to see that the water hits and then it goes back. Has anyone visited Mumbai, Gateway of India? No one? Go there. You will find very wide sea wall that is there. So the water strikes and then goes back. It does not come inside. Okay, that's the first one. Then you have revetments and rock armor. This is also something that you have seen with respect to movies which have been shot in Mumbai. Anyone who has seen Businessman? Mahesh Babu? Okay, you have seen. Who else? She has seen. You have seen. Nobody else. How many of you have seen Akshay Kumar's Holiday or Munna Bhai, MBBS? What movies have you seen, man? I ask you latest movies, you don't know latest movies. I ask you old and they're classic movies, you don't know classic movies. What is it? How exactly have you survived this time? Don't tell me COVID was the time when everything went away. Every time I ask him something, sir, COVID times. He is also like that, sir, second year COVID times. Now these are movies. Okay. So everyone who has seen Businessman and everyone who has seen Munna Bhai. Okay. So whoever has seen Businessman, there is a particular scene where this Mahesh Babu who actually meets Shruti Hassan, I guess. Oh yeah, Kajal Agarwal and her friend. Okay, so the path that he is walking upon, that is a stretch on Marine Drive. Okay, so on the left side of that you see a lot of unusual kind of blocks which are there on the seaside. Whoever has seen Munna Bhai, this is a very common sight. When he actually goes and sits there before he gets to know that okay, his family is coming down. No, not family is coming down. Yeah, when he's he's refused the admission to the medical college, he sits there. Okay, and when he sits there, so the covering of this entire scene has taken from the behind, and you see that a lot of you can say those rocks are found there. Okay, now that is what is known as revetments and rock armors. Okay, irregularly shaped objects which are here. Okay, then you have groins. So when you talk about groins, yes. Oh. So when you talk about groins, they may be concrete, timber or stone structures which are built perpendicular so as to stop the water from coming inside. Okay, and breakwaters are basically installed a little bit ahead deep into the sea. Okay, and they are basically there to reduce the wave height. Okay, so this is basically the way in which you find these particular things happening. So I'll just show you. This is basically a sea wall. Okay, have you seen these structures in those movies? This is what is revetment and blocks. Okay, this is sea wall. This is a sea wall, but this is a return wall. Why? When the water is going to hit, it is going to turn back. Okay, a closure version is this. Okay, but you will not find them without these blocks. They are irregularly shaped blocks, sometimes rocks, which are directly dumped into the sea. Why? Because they have enormous amount of friction surface. So they not only absorb the energy of water, they also let the water go beneath them. Okay, so this is how you prevent coastal erosion. Now this is what is known as the rock armor revetment. Okay, now this is Bristol, United Kingdom. Okay, this is groins. This you might have also seen with respect to anyone who has gone to Puducherry. Not sure. See, I am not gone to the west coast beaches. I am not very sure of that. But this is something which is found there. You have gone there? Which beach? Did you see this? They are actually installed here, somewhere to the distance. Vertical structures. You have not seen that. Okay, this is basically there. You will find it there also. You will find it in Serenity Beach as well. Okay, they are groins. And this is breakwater. So usually when you talk about having any kind of ports which are developed, okay, so they are basically the ones which are used, so that you can also stabilize the ports. Anyone who has seen or heard Burj Al Arab? What is it? It's not an artificial island. Burj Al Arab. Where exactly is this? Dubai. Abu Dhabi is famous for only one thing, World of Ferrari. How many of you like roller coasters? Only you. Nobody else. You will find the world's fastest roller coaster in Abu Dhabi, World of Ferrari. And that's a Ferrari car in which you sit. Okay. So when you talk about Burj Al Arab, this is a hotel. So that is actually a super luxury hotel which claims to be 7 stars, but we don't have more than 5 stars to give. Okay, so it has very premium facilities and everything. The foundation of this particular hotel has got a lot of these. They are there to stabilize the structure of the sand, because the foundation of this particular hotel is on sand. Okay, so in order for the water to prevent that coastal erosion, a lot of these blocks have been dumped inside it, and then that particular structure has been built over it. The same is the case with your Date Palm Island as well. Okay, so in Date Palm Island you actually have Atlantis, you don't have Burj Al Arab. Burj Al Arab is different, Date Palm Island is different. Okay, and Jebel Al Ali is different. There are 3 different you can say Palm Islands. So do you understand this? So watch there is a documentary I think from Discovery that basically tells you about the construction of the Burj Khalifa and Burj Al Arab. You will understand the use of this. Okay, first of all they used hexagonal panels to cover the sand, and above that they put these particular kind of structures to stabilize the sand. Okay, so this is how you prevent coastal erosion. Is this clear? Now coming to the next disaster, cloudbursts. Okay. So when you talk about cloud burst, so the name itself is explanatory, bursting of a cloud. Okay. So when you talk about rainfall, rainfall is actually the discharge of liquid water or snow from the cloud when the weight of the cloud is such that it is not able to retain this water with itself. Okay. So when the weight of the liquid droplet is higher than the air resisting it, you have rainfall. Okay. So that is the simple phenomenon of rainfall. Why exactly rainfall occurs? Because there is water on the surface of the earth. So this particular water which is there on the surface of the earth, it will start evaporating during the daytime. So when it evaporates, all this water rises up into the atmosphere. When it is rising up into the atmosphere, the temperature of air in the atmosphere keeps on reducing. Okay. And when it keeps on reducing, there is a certain temperature which is known as dew point temperature. Okay. So you have dew point temperature. Now this is the temperature at which any vapor, water vapor, turns into liquid. Okay. So with respect to air, the water vapor which is present in the air is known as moisture. Okay. So when the air rises up into the atmosphere and it cools down, there comes a certain temperature which is known as dew point temperature. At this particular temperature, whatever water vapor are present in the air, it separates out as liquid. Okay. And then this liquid, when it becomes an assembly of a large number of liquid particles together, it turns into a cloud. Okay. So anytime you see a cloud in the atmosphere, it is basically condensation of the water vapor that was there in the ground once upon a time. Now the point is, after this particular water vapor has condensed, okay, so initially it is white because the weight of water which is there inside this particular cloud is not very high. But as the water keeps on getting inside this particular cloud, as this particular cloud becomes bigger and bigger, it turns grayish. Okay. And these grayish clouds then become very, very dark, sometimes even to the range of blackish. Okay. Why? Because at the bottom of that particular cloud, liquid water gets assembled together. Okay. And when liquid water gets assembled together, there comes a point when the cloud is so heavy that it is not able to hold its own weight. And then this liquid water starts discharging into the air. That is what you know as rainfall. Okay. So this rainfall, an extreme version of that is known as cloud burst. Okay. So rainfall actually has various kinds of, you can say, grades. Okay. Just like when you talk about the rainfall which happens here, that is convectional rainfall. Why convection? Because when you talk about the water vapor getting vertically evaporated and traveling in the vertical direction towards the sky, that is known as convection in geography. Okay. So what exactly is that? The vertical movement of the air towards the atmosphere, that is convection. The horizontal movement of air over the ground is known as advection or winds. Okay. So in that particular regard, what basically happens is that the clouds over Bangalore right now which are causing some amount of rainfall is convection. That is how most of the rainfall happens. Okay. If you have seen the Talakaveri winds, Talakaveri wala reel, there what you exactly find is that is orographic. Meaning that when the air is moving, it encounters a mountain or a high altitude object. Okay. So when the air strikes this surface, it starts moving up. So when the air starts moving up towards the top of the mountain, the temperature in the surrounding area keeps on reducing. And because of this, the dew point temperature is reached. And because of the reaching of the dew point temperature, cloud formation takes place. Now what is going to be different is the rate at which the air is going to rise up. Okay. So if the altitude is very high and the slope is very sharp, so at that particular moment of time, the air rapidly rises up. So the more rapid the rise of the air, the greater would be the condensation of the water. Okay. So as quickly as the air rises, the more amount of condensation will happen at a lower altitude. Okay. As slower as it rises, the lesser amount of condensation is going to happen at a lower altitude. Okay. So because of that, what happens is that we have torrential rainfall. So torrential rainfall is very heavy rainfall within a span of one day. Okay. But the third one is the extreme version which is known as cloud burst. Okay. So cloud burst is basically an aggravated kind of rainfall that is going to happen. And why exactly is this rainfall going to happen? Because the air is rising very quickly and the air has a lot of moisture. So when it has a lot of moisture and it is rising very quickly, very near to the ground, it will make a very thick cloud. And this cloud will have so much amount of water that it completely collapses from the bottom. Just like the tearing of any kind of shopping bag which is overstuffed with things. So everything comes down at once. That is cloudburst. Okay. So the effect of cloudburst, rainfall, torrential rainfall will be the same. They are going to lead for inundation or flooding. Okay. So the associated hazard with this would be first thing flooding. Okay. Then second thing landslide. Because there is enormous amount of water that is flowing, so it is going to result into erosion of soil, it is going to loosen the soil and then it can cause landslides. Okay. It can also cause the damming of the river water that was associated with landslides. So cloudbursts are a dangerous phenomenon, but they are usually localized to the regions which are high altitude mountains. Okay. So that is basically what is cloudburst. So technically what exactly is the definition given by IMD? So Indian Meteorological Department gives you the definition that when the rainfall is at the rate of 100 millimeter per hour or more, okay, that is occurring over an area of 20 to 30 square kilometers. That is something which is going to be known as cloudburst. So over the surface of the earth, the area should be at least 20 to 30 square kilometers wide, and then subsequently the rate of rainfall, the amount of rainfall that is falling down per hour is at least 100 millimeters. So 100 millimeters is an enormous amount of rainfall that can happen in one particular hour. Okay, that can immediately fill up the entire region. Okay, so what basically happens is that cloudbursts are actually the one which result from very low pressures and sometimes microclimates as well. Okay, so this is something where we see that mountains are the one where the probability of cloudburst is going to be higher than the other regions. Why? Because in the mountains, at the top of the mountain, if there is a low pressure existing, it is going to attract the winds from the bottom. Okay, the greater the low pressure, the faster the wind flow, and when the wind flow is going to be faster, the greater would be the amount of condensation. That is going to have greater amount of possibility. But surprisingly, this particular year, cloudburst has also been seen over plains. Okay, one such example has been the rainfall in Bilaspur, Chhattisgarh. Okay, so when you talk about the region of Bilaspur in Chhattisgarh, it received 37 hours of continuous rainfall. Okay, now this is basically a very plain type of region, no mountains, nothing, but it received 37 hours of continuous rainfall, until the extent that people actually started using boats over the main roads, okay, in order to commute from one place to other. So that has been one of the exceptional examples. Usually it happens in the region of mountains. Okay, and then this is something which is very difficult to predict because it is very expensive to actually monitor cloudbursts. Okay, so it is very difficult to predict that where exactly cloudburst happened, but what happens is that if it happens at a high altitude, so from there when the water is going to come down, it is going to wash away the entire region at the downstream. Just like you saw on that day when I told you about Dharali, Uttarakhand, that was the result of cloudburst. Because of that it happened. Okay, so the first you can say occurrence of this is going to cause floods. Okay, so the most easiest way of this is convective clouds. Why? Because when the hot air is rising vertically upwards, it continuously cools down. Okay, and when it is cooling down, this is something which is going to condense the water vapor and create clouds. Okay, bigger the cloud, the more amount of rainfall it will have. Okay, I'll just show you from the image. See, now what happens is that when the air is actually moving towards the mountains, now imagine that there is a low pressure zone here. So what you have to understand from this, that first of all, air moves from high pressure to low pressure. So because of this particular low pressure zone which is existing at the top, what is going to happen? It is going to attract the winds from all the sides. So from all the sides, the winds are going to approach this particular region to fulfill the low pressure side. Okay. Now the point is, when this low pressure is existing at the top, the winds will start rising up the slope. Okay, when it is rising up, because of the high altitude of the mountains, it starts cooling down, and because of this cooling down, what happens, very rapidly it generates these clouds. Okay, while it is continuously going up, this cloud is getting bigger in height. Okay, and by the time air reaches towards the top, the cloud actually is very big, very near to the ground. Okay, and because of the continuous coming in of the winds, a lot of condensation happens. That water all of a sudden collapses, and that is something which results in cloud burst. This is what happens. Okay, so once the wind reaches here, it then comes down on the other side, which is completely dry. Okay, but this side you will be having all the havoc. Okay, you will be having flood, you will be having extensive soil erosion, you will be having landslides. Okay, all of these things are going to happen on this side of the mountain. So when you talk about the region of Uttarakhand, you talk about the region of Himachal Pradesh, they are the ones which are having this particular thing happening very frequently. Okay, Jammu Kashmir, this happens very frequently. So that is why in this particular time, so this is how the discharge looks like. Just see how exactly this discharge is happening. Why? Because it has torn from there. So it is like someone is directly pouring a bucket of water over you. Okay, but not just one bucket, many buckets together. What is going to happen? This is going to happen. That is cloud burst. Okay. So when you talk about cloud burst, what exactly are going to be the influencing factors? The first one would be wind direction. In which direction the wind is blowing? Is it blowing towards the mountains or away from the mountains? Okay, so based upon that, what happens is that when the mountains are going to attract the winds because of the low pressure zone, everything is going to come towards the mountains. Second, this wind must also have moisture. If it does not have moisture, it will not condense into clouds. Okay, so it should have enormous amount of moisture. That is why cloud burst as a phenomenon is only going to happen during rainy season. It does not happen in other seasons. Okay, then at the same time, what is going to happen? At the top, you will be needing a consistent low pressure zone. Okay, so for that, the height of mountain is also going to matter, and the shape of the mountain. If the shape is gentle, the slope is gentle, air that is rising will be slower. So when the air rises slowly, the condensation will also happen slowly. Okay, but if the slope is sharp, the mountain is high altitude, at that time what is going to happen? You will rise very rapidly. So when the rise is rapid, at that particular moment of time, you are going to see that you are going to have very huge formation of these clouds. Okay, so that is the next thing. Moisture content. Greater the moisture content, the more disastrous this event would be. Okay, so if the moisture content is less, you are not going to find any kind of you can say dangerous situation. Just like when you talk about that reel of Talakaveri, at that one we were definitely in the cloud, but it did not have such significant amount of condensation. Okay, so that is why in that particular reel also you could not see the droplets falling down. They were definitely coming on our faces, but it was not very aggressive. Okay, but when you talk about the regions of Himalayas, there this becomes very aggressive. Okay, so this is basically the you can say the magic of moisture. So here at Talakaveri, the height is not so high. Okay, but when you talk about Himalayas, the average height is somewhere around 2500 meters above the mean sea level. So what is going to happen? You will have to rise up higher. So when you are rising up higher, the condensation is going to be more, and the size of the cloud will be proportionately more. Okay, why I am on and on referring to the same reel that we are talking about? Because that reel has a lot of you can say elements that you can study from. It's not just what I am saying there, but it's also about the surroundings which we are trying to cover. What exactly is in that reel? Okay, so look into that reel very carefully. Then temperature differences. So temperature differences between the two sides of the mountains. Okay, so when the two sides of the mountains are at different temperatures, that is going to give rise to a pressure difference. Okay, so technically it means that, let us say this is the slope of the mountain. Okay, so now what is going to happen if you want to attract the winds on this particular side? Okay, so your low pressure should be here, but at the same time, if the wind is to go down on this particular side, it basically means it is going to come down because of gravity, right? So then what is going to happen? Here it should be hot. On this side it should be relatively cold. Okay, that is when the wind here is coming and it is cooled down. Now because of the heaviness it is going to come down. When it is going to come down, it is dry. So that is something that you will have to have. You will have to have as a difference. Okay. Then atmospheric pressure systems. Now this is something which is going to be related to the way that even the jet streams are going to be present. If you remember, on the first day I told you that jet streams can aggravate or stabilize the weather in a particular place. Okay. So jet streams are basically narrow bands of air that move high in the atmosphere, very fast flowing air. Okay. Now these particular air, you can say air bands, are actually existing due to the temperature difference between the two sides. Okay. So at the level of equator, when you talk about it, the equator is basically the place where the temperatures are always warm, and at the poles the temperature are always cold. Now what happens is that with respect to the earth, when we read climatology and oceanography, we see that the heat actually travels from the equator towards the poles, and the coldness of the poles comes from the poles towards the equator. Because of this, we have a temperature stabilization. Apart from this, the second element of temperature stabilization will be the presence of atmospheric gases all around, that is greenhouse effect. So these two are actually responsible for having you can say the stability of temperature on the surface of the earth. Now basically what happens is that here we have two jet streams that flow over the entire earth at an altitude of about 8 kilometers above the surface of the earth. So at this particular you can say region, the entire jet stream is flowing. But because of the flow of the jet stream, it can push clouds from one side to the other. Okay, and at the same time it can clarify the entire weather as well. Now just imagine that condensation is happening in this particular region. Okay, in a particular mountain the condensation is happening very fast, but at the same time jet stream is also flowing in that direction. So what is going to happen? The jet stream is going to push this entire cloud system to some other place. So the cloud burst is going to be prevented there. It will definitely cause rainfall, but somewhere else. Okay, so that is the local atmospheric pressure systems that exist. Then depending upon the season, the moisture is going to be different. When we talk about the rainy season, the rainy season comes after the summer season for us. So at that particular moment of time the air is warm. So when the air is warm, it is able to absorb more amount of moisture, and then subsequently what happens, this moisture, when it reaches the surface of the land and it rises up, it condenses that moisture out. During the times of winters, the air temperature is already low, so air is not able to absorb more amount of moisture. That is why during the time of winters you feel that your skin actually needs more amount of moisturization. Have you seen this, that during the winter times the consumption of moisturizer goes up? Why? Because the air is dry, and when the air is dry it makes your skin feel dry. But during the monsoon time you may not be going with that amount of moisturization, and this goes especially with the girls. I'm not sure the boys use it. Do you know anything beyond Vaseline? You know? Tell me if you know it. That's what. Ask them. What are your moisturizers, ma'am? Sorry? Nivea. Okay. Who said who doesn't use it? You don't use it. You don't use it. Okay. So you use something else, coconut oil or mustard oil, something like that. Naturally it is nourished. Very nice. But still you might be knowing the brands. Yeah, tell me that. See, even she is not believing that part. Some gel she uses. See, this is the difference. When I said, do you know anything more than Vaseline, all the boys agreed, no, we don't know anything. She is only doubting that you don't use moisturizer. Okay, tell me some names. Let the boys also have their knowledge circle enhanced, no? You said Nivea, I guess. Yeah, then Ponds. Yeah, that is also one of those. I forgot that. Yeah. Ma'am, you can also participate, no issues. You can tell your favorite moisturizer. Whatever you use. You use it or not? So that is what I am trying to teach you here with respect to the season and climate. Okay, Vaseline and Ponds. You just want to sound innocent in front of me, no? That okay, you guys don't know much. Huh? See, this entire cosmetic industry is running for you guys, not for us. I told you, when we go and ask for something cosmetic, they'll only tell you this is charcoal. This is what they're going to tell you. Face wash, charcoal. Toothpaste, charcoal. Okay, except for our hair gel, everything is charcoal. I don't know what exactly are we going to have with so much of charcoal. Okay, they are trying to make us bright or they are trying to make us dark. I don't really understand what exactly is the utility of charcoal. Face wash you guys use? What is the essential ingredient? Have you seen? It will always have one grayish thing that is known as activated carbon. Yeah? Salicylic acid is different. Salicylic acid or salicylic gel actually thickens anything, just like you have gelatin. So when you add any gelatin to any liquid, it thickens like ice creams. Salicylic gel is like that. For making ointments, for making any type of paste, you use it so that it becomes thick. But what is the ingredient? Charcoal, nothing else. Go and see. They'll tell you, yes, some amount of silver granules. Okay. So in 180 grams of that, you will be having only 5 grams of silver granules, not more than that. That is what we can afford. Okay. Because you also get it at 300 rupees or 400 rupees, no, not more than that. See the blank faces, you will understand. We don't have much choices. With you, the choices come with respect to product. Okay, you have various types of ingredients, jojoba beads, we don't even know what is that. There is something which is known as shea butter, we don't know what it is that. Yeah? There is something which is known as shea butter. Do you know what it is? Yes, ma'am. Whatever you are going to say, we are going to accept. We don't know what is shea butter. That's the thing. Okay. So, this is exactly the discrepancy. On one part of the island, we have those people who do not have any choices. On the other part of the island, we have those people who have so many choices, but they don't know what they use. That's the difference. You even have so many different varieties of colors, right? Every time you use a product, there will be a different color. Just check what the boys use. That will always have 2 or 3 colors: white, grey, blue. Trust me. And we are all here representing those variations only, even in our shirts. Okay, that is just an exception. Sometimes that comes up, but these are the usual colors that we have. And still you will find the same kind of patterns. Checks, lines, planes, and this is printed. Done. Anywhere you go in the world, you are not going to find any other pattern for us. But just look around you, 4 have got 4 different patterns. Okay. So that is how it is. Fun to be around, right? So when you talk about seasonal and climatic variations, there also you see this, that with respect to the season, your moisture content is going to change. And based upon that, the probability of cloudburst is going to change. Okay. So cloudbursts are a very rare event during winters, because during winters, the air which comes on India or which goes from India is not having that amount of moisture. But yet there is a possibility. Okay. When the western disturbances come towards India, and if those are the ones which are very moist, at that particular moment of time, you will find another bout of cloudburst, especially in Uttarakhand and Himachal Pradesh. Okay. So that is basically the factors that influence you can say the formation of clouds and causing orographic rainfall. Okay. So tomorrow when we meet, we are going to go ahead with management of floods, which is going to start from here. Okay. Because from here the flooding concept starts. So we will be seeing 3 different types of floods, but the management is roughly the same. The first one is this. The second one we are going to see is glacial lake outburst flood, JLOF. There also I just have to tell how exactly this flood comes up. I don't have to tell you how to manage the flood. Flood management will be roughly the same. And the third one we'll be seeing will be urban flooding. Okay. Then we'll be looking into other things. Any doubts till now? Chalo. Then you are free to go. Before you all die, I'll leave you guys. Bye bye. No doubts now? Chalo. Take care. Thank you so much.